Radiation is everywhere. In sunlight, in hospitals, even inside your own body. Every day, we interact with radiation, often without even realizing it. But despite its presence, most people have only a vague idea of what radiation actually is. So what exactly is radiation? Is it something dangerous that we should always avoid? Or is it something essential that plays a critical role in science, medicine, and modern technology? To answer these questions, we first need to understand what radiation really means. At its core, radiation is simply energy moving from one place to another. This movement can happen through empty space or through a material medium. So whenever energy travels away from its source, we are observing radiation. In physics, we define radiation as energy that is emitted from a source and propagates outward through space or matter. This definition may sound simple, but it captures a very powerful idea. Energy does not always stay confined, it spreads, it transfers, and it interacts with its surroundings. Now, radiation exists mainly in two fundamental forms. The first type is electromagnetic radiation, and the second type is particulate radiation. Understanding these two categories is essential, because almost all radiation phenomena can be explained using this classification. Electromagnetic radiation includes visible light, X-rays, and gamma rays. These forms of radiation travel as waves, and remarkably, they all move at the same speed, the speed of light. This type of radiation does not require any medium, which means it can travel even through vacuum, such as in outer space. All electromagnetic radiation belongs to a continuous range called the electromagnetic spectrum. The only difference between different types is their energy, or equivalently, their wavelength and frequency. At one end, we have low-energy radio waves, and at the other end, we have extremely high-energy gamma rays. Even though they appear very different, they are fundamentally the same phenomenon. Now let us move to the second type, particulate radiation. Unlike electromagnetic radiation, this consists of actual physical particles. These include alpha particles, beta particles, and neutrons. These particles have mass, and some of them also carry charge. Because of this, their interaction with matter is often much more direct, and sometimes more intense. So we can now clearly compare the two types. Electromagnetic radiation is energy traveling in the form of waves, without any mass. On the other hand, particulate radiation consists of particles, which have mass, and may also carry electric charge. This difference plays a crucial role in determining how radiation behaves when it interacts with matter. Now we introduce a very important concept called ionization. Some types of radiation have enough energy to remove electrons from atoms. When an electron is removed, the atom becomes charged and is then called an ion. This process is known as ionization. Ionization is particularly important because it directly affects the structure of matter, including biological tissue. Based on this ability, radiation is classified into two types: ionizing radiation, which can remove electrons, and non-ionizing radiation, which cannot. Ionizing radiation includes X-rays, gamma rays, and many types of particle radiation. Non-ionizing radiation includes radio waves, microwaves, and visible light. This classification is extremely important, especially in fields like medical physics and radiation safety. Radiation is not just a theoretical concept, it is all around us, in real life. In medicine, radiation is used for imaging and for treating diseases like cancer. In nature, we receive radiation from the sun, and even from cosmic sources. In industry, radiation is used for testing materials and sterilizing equipment. So radiation is not something distant, it is deeply integrated into our daily lives. So this brings us to an important question. Is radiation dangerous? The answer is, it depends. Radiation is not inherently harmful, but its effect depends on the type, the energy, and the duration of exposure. That is why we follow safety principles, such as controlling time, increasing distance, and using proper shielding. These principles help us use radiation safely and effectively. Let us now summarize what we have learned. Radiation is energy in motion. It can exist in two main forms, electromagnetic and particulate. Some radiation can ionize atoms, while some cannot. And most importantly, radiation is not always dangerous, its impact depends on how we interact with it. In the next video, we will explore the concept of radioactivity and understand half-life, which tells us how unstable atoms change over time.